This is the pre-lab lecture on the investigation of density. This lab consists of two parts. In part 1, you will determine the density of an unknown metal given a set of volume and mass data. You need to enter the volume and mass in a spreadsheet, make a graph, do a linear regression, get a linear function, and based on that function, you determine the density. So first, let's look at how we can determine the volume of a solid object with an irregular shape, such as a key. You need a graduated cylinder. You pour some water in, you measure its volume, and then you immerse the key in the water, measure the volume again, take the difference. The difference in volume is the volume of the key. So this is how we determine the volume of a solid object experimentally. But in this part, you will be given the volume and mass data. And then, using Excel or OpenOffice, you can enter those data and plot a graph. Make sure you have this volume as your horizontal axis. Mass is the vertical axis. So really, the left column should be volume. The right column should be mass. And then you do a linear regression, display the linear function, and also the r squared value. If r squared is 1, you have a perfect fitting. If r squared is 0, there's no correlation. Your function does not fit the data at all. It is better to set the intercept of the linear function to 0. This is because a non-zero intercept has no physical meaning at all. Remember, mass is equal to density times volume plus what? Plus 0. However, if you use OpenOffice, it may be impossible to set the intercept to be 0. That's fine. You will see a very small intercept. That's acceptable. Be sure to give your graph a title. Be sure to label the horizontal and the vertical axis and include proper units. Now let's look at part 2, density column. In this part, you will measure the volume and mass of 5 different liquids. They have different density values. And then you will use these 5 liquids to make a density column. After you make this column, you can measure the range of the density of 5 different solid objects. Again, you will not be able to determine the exact density value of these objects. You can only determine the range. So now let's talk about the experimental procedures. Again, you will use a graduated cylinder to measure the volume of these liquids. Make sure the cylinder is clean and dry. If it's not, use water, use soap to clean it, and use paper towel or air dryer to dry the cylinder completely. And then measure the mass of the cylinder first before you pour in any liquid. Obtain the mass of the graduated cylinder and then pour some water inside the graduated cylinder. Weigh the cylinder with water again. Take the difference and you get the mass of the water. And then you measure the volume of the water. by reading the scales carefully and by estimating one additional digit. The unit is usually milliliter. Repeat these procedures for 40% KBr solution, ethanol, glycerol, and mineral oil in that order. This is because it's really difficult to clean glycerol and mineral oil. You will have to use soap to clean this to liquids. They are both very viscous. On the other hand, it's really easy to clean water, 40% KBr, and ethanol. Once you obtain the mass and volume for each of the 5 liquids, you should be able to hand calculate the density. Using this equation, density is equal to mass over volume. And make sure you have the right density values. Ask your TA to check your numbers. This is because we want to pour the liquid with the highest density first into the density column, followed by the second, third, fourth, and the fifth liquid in the order of decreasing density values. So again, pour the 5 liquids one by one into a large graduated cylinder like this. 5 different liquids. They are colored so that you can easily see the interface here, 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 and here. You may see different colors. That's fine. It's just we use different dyes to give these 5 liquids colors, different colors. Again, the bottom liquid has the highest density. The top layer has the lowest density. Be sure to watch this YouTube video on how to make a density column. After you make the density column, you can measure the density range of solid objects. You simply get 5 different types of solid objects, throw them into the column. Let's say if one object floats between these 2 layers, the orange and the green layer, and we say the range of the density of this solid can be determined. It's between this density and this density. And this is how you record the range of the density of these solid objects. Finally, you collect, clean, wipe dry, and return these 5 solid objects. We reuse them. How about the liquids? They should be dumped in the waste bottle inside a fume hood. And then, before you leave the lab room, clean up and ask your TA to check and sign your lab notebook.